Been here since Monday, heard a lot of great conversations, and everything I was going to tell you this morning has already been said. All right? So I'm not going to talk about the min-max of electric vehicles. They were great presentations. Visually had a great one, talked about smart and managed charging, the plug-and-play panel, Austin Energy, Con Edison, CPS. Told you everything you needed to know. So what am I going to tell you? Thank you very much. It was a pleasure seeing you this morning. Now, here's what I want to talk to you about. I want to give you just an insight to the way I think about things. I've been in the electric utility industry. How many people have been born after 1978? Raise your hand. All right. Well, that's when I started. And I started Consolidated Edison, an electric generation planning engineer. But since then, I've been around the world. I've run some of the largest electric and gas utilities on the planet. I'm not going to go into the resume. I don't say that to sort of puff myself up. I just say because of all the things I've learned, and I want to share some of them with you. And the first thing I want to share with you is that the traditional utility model is dead. Okay? And if it's not dead, it's on its way to being dead. Why? Because it's built on two foundational items. One, economies of scale of generation. And two, the fact that you can't store the product. Both of those don't work anymore, right? It used to be the bigger you built the power plant, the cheaper the energy got, and that drove us all to building load, right? Think about Sam Insel. That was the reason we have these big franchise areas. That's the reason why we get franchised customers, to give us the load to build big plants, and the more load you build, the cheaper it gets. That hasn't worked since 1968, right? And what it's been replaced with is economies of manufacture. The more solar cells we build, the cheaper they get. The more wind turbines we build and manufacture, the cheaper they get. The more batteries we manufacture, the cheaper they get. But building load doesn't make them cheaper, okay? And the second one is we are getting to the point where we can store energy economically. Now, I'm not going to go into all those details, but if you want to understand the implications of that, go on the internet and start to look at agriculture before and after refrigeration and meat processing and delivering before and after refrigeration. It radically changed those industries, and it will radically change ours, okay? So if the old one is dead, what's coming next? Oh, and I want to give you another thing. You know it's dead. You've been talking about it for 4 days. You've been talking about all the symptoms of this dead business model, right? You've been talking about customer satisfaction or the lack thereof. You've been talking about reliability and resilience or the lack thereof. You've been talking about equity and affordability or the lack thereof. And you've been talking about environmental impact, okay? Those are all, and I would argue, signs of a business model that no longer work for us. So what's coming? Well, I read this fantastic paper in 1980. Okay? You can find it. It's on the web. It's called The Homeostatic Control of Electric Systems. And it was written by two professors out of MIT, one who has passed and one who's still doing great work, Fred Schweppe and Dick Tabors. And it was written to sort of justify and support time-of-use pricing. This was in 1980, all right? And they got to the point where buried deep in the paper, it said something very interesting that caught my attention. And I started my career Consolidated Edison in 1979. I read this paper in 1980. And it said that the value of the last electron consumed by an individual end user is different at any given point in time from every other user. And therefore, there's an opportunity for end-use arbitrage. And it's through this end-use arbitrage that you can bring the system to equilibrium, homeostasis, and you will have the most efficient electric system you can. Talk to Mr. Pareto, okay? But when they wrote this paper in 1980, they envisioned the technology. They had a black box which would schedule power based on price signals sent from the utility. Now, the paper concluded by saying that with advancements in computational capability and telephony, this future is not that far away. You can determine whether it's here or not. You've all been talking about these things. You all live in this stuff, right? But what's the implication of that? The implication of this is that the idea of end-use arbitrage really says a lot of things. And I'm going to update what they said, because they said every end user. And I'll tell you, every end-use device. And every end-use device, when it gets smart, will run our systems. It will disintermediate the utilities. It'll disintermediate the customers. The system will run itself based on smart devices. How many? Billions. Look at any article on the IoT, Internet of Things. Currently in North America, 5 billion things connected. Every device has the potential of being smart, has the potential to learn, has the potential to schedule, trade electricity, and give customers absolute control. Not that they're controlling it, but their devices are. You will build the most efficient system and the one that is most responsive to customers, right, as they learn. The other implication of this is it requires us to have an extremely reliable distribution grid. Now, I've been in the industry a long time. The last thing we think about is the distribution grid, right? Now, not the people who work on it, right, Sean? But everybody else, we don't think about it very much. We think about generation, we think about transmission, bulk power. But the reliability and resilience of that distribution grid will become much, much more important. And if we have these smart devices, what that will lead us to is the smart, adaptive, self-repairing grid. Okay? When is that going to happen? I don't know. I've been at this for 48 years, and I've been trying to find this for 48 years. But when you get into a room like this, and you think about what we've been talking about, right? What we've been talking about since Monday, you are all the people who are going to make this happen. And that's why you all have to become great friends and help each other and work together. The utilities, public power, investor-owned power, technology providers, regulators, policymakers, to make this happen. The speed at which this happens will depend on our ability to work together, to innovate, to share ideas, and to move forward, okay? I was at a high school presentation a couple of weeks ago, and a 17-year-old said, ceaseless devotion to a mighty task. Well, here's your mighty task. Can you bring that ceaseless devotion? Get on with it? So, now let's talk about mobility, eMobility, because here comes a node, right? Now remember I talked about 50 billion things? 50 billion things that are going to have to talk to each other in real time? 50 billion things that can either be a source or a sink of electricity? Let's talk about eMobility, because if we believe this future, and that's up to you, I do, if you believe it, we should start acting on that belief. And anything new, we should anticipate where it's going. We can talk about the utility of the future all we want, but we have to act on the belief that we have about what it looks like. So let me show you the way I've been thinking about it, okay? This is a framework. It's called the Strategic Temple. My strategy mentor, Jose Elias Alvarez, taught me everything I know about strategy, and this was a very simple model. He called this the Strategic Temple. You have a foundation, which is where you have your processes that deliver certain capabilities, which are your columns, and your roof are the outcomes you want. So let's just go to the roof. Support load growth in a safe, responsive, sustainable, equitable manner. Okay, that's how I think about it. Even though growing load is not what we want to do, we know that the path to zero carbon will require massive electrification Load will grow. Rewiring America says it will triple. And here's the key. We cannot build it fast enough, and if we did, you couldn't afford to use it, okay? So we have to do it smart. So supporting load growth in a safe, responsive to who? Responsive to our customers, sustainable, that's affordability, that's profitability, and equitable manner. We've talked about these things all week. I'm not going to go into it. So where do we start? Let's go to the foundation. Customer experience manager. You have to become intimate with your customers. You have to rebuild that trust. You have to really, really, really focus on the customer. So if you're not thinking about the customer all day long, you're not thinking hard enough. That's where it starts. And you have to build that capability set into your business. The next, asset performance management. Now we're talking about the reliability of the grid. We've been talking about that all week. Being able to diagnose, call it asset management, call it critical infrastructure protection. We have to make sure we have a grid that can support this. And these are processes within your business. The last foundational piece, distributed connected load management. You can call it DERMS. I don't, because if I call it DERMS, a lot of people switch off, okay? So let's talk about what it is. It's being able to manage things that are connected to our network. Because in our view, everything connected to the network is part of the network, right? That's that future we're building to. And so, in rolls on 4 wheels, the battery, eMobility, all right? We've been talking about it. So let's see, if I was expecting my franchise territory, my service territory to be exposed to rapid growth of electric vehicles, what do I need to know? And how do I want to deal with it? Well, first thing, discoverability. I have to be able to know they're here, right? Not just the ones that are owned by people who are my customers, but the shooting stars, the ones that fly through the franchise area, the ones that come in for a visit and go away. When they're here and when they're in my area and I have to serve them, I need to know they're here. And once I can discover all these vehicles, the next thing, I need visibility. I need to be able to understand where they are, what charge level they have, how they're going to operate, how they're going to impact me. So it's not just finding them, it's being able to have an insight and visibility into them. And telemetry from these vehicles is there. You can do that, right? And after we have discovery, visibility, we need predictability. On the fleet conversion panel, I think somebody said school buses are the perfect first example to make electric. Why? Because we know where they are. We know where they start the day, we know where they're going, we know where they're coming back. We can find patterns of vehicle use once we can identify and have visibility. There are patterns, right? This is where machine learning comes in, right? There might be on the edges things you can't see, but for the most part, you can predict pathways, charge levels, time to recharge, and this allows us to plan better. So once we have that, next pillar, operability. This is where we spend a lot of time talking. This is the charging and discharging, whether it's vehicle to home or vehicle to grid. This is the operability. But not only that, this is the way you pay for your energy. This is all the transactional elements of eMobility, all right? Next one, serviceability. Because once it's part of our network, we have to make sure we can maintain it. I had an electric vehicle program in Australia when I was the CEO of City Power, of AGL. I was also City Power. That was a little bit earlier. We had the all-you-can-eat, $1 a day, fully carbon offset rate if you had our smart meter. And we knew that once we started tinkering around with people's cars, if something didn't work, it was our meter, our charge system, we had to make sure that we could support it. And we developed a concierge service that if we monitored and there was a problem, we would immediately get out there and remedy it. But serviceability becomes really, really important. And the last one, which may not be so obvious, is, auditability. We are vested with the public interest. We have to be accountable for what we do. I call it auditability. It's records of our performance. It's being able to learn. It's being able to track. It's being able to support the decisions we're making. So this is that framework that I just wanted to put out in front of you, because when we start to think about when electric vehicles are coming and our future that I sort of spoke to, this is what it looks like, okay? This is what I would want if it was my business. And here's the key. This applies to almost everything else you're going to hook up to your network. So electric vehicles not only gives you a chance to better serve your customer, be more intimate, be able to augment your grid, be able to rebrand yourself with your customers in a very, very positive way. It is the wedge technology to opening up the full potential of distributed resource management and control. Once we're in with vehicles and we're intimate in controlling them, how far away is the lighting? How far away is the HVAC? To be able to build this future of this full value chain of service for profitable supply of energy, for enriching our customers, for being able to build that utility of the future. So I'm going to stop there. I really appreciate your attention. Hopefully some of this stimulated some of the thinking, but remember this: ceaseless devotion to a mighty task. Thank you very much. It was a pleasure talking to you this morning.
Thank you so much, Andy.